What's going on, y'all? This is Ben Codes, working through technical difficulties. So just gonna pick up on, well, pick up on going through arrays. We're going through JavaScript.info, eloquent JavaScript, data structures and objects and arrays, and then we're gonna go through at least one Cold War today, like fundamental JavaScript fundamentals, and then from there you know from there it's going to be like a marathon type thing. So we're going to do this, and then we're going to listen to class 20, and my goal, I'm gonna be here all day, to be honest. So all right, let's get into it. This is from that last one, so I'm just gonna go ahead and comment that out. Cool. Array methods. Arrays provide a lot of methods to make things easier in this chapter, where they are split into groups. Add, remove items. We already know methods that add and remove items from the beginning or the end. Excuse me. R.push adds items to the end. R.pop extracts items from the end. R.shift extracts items from the beginning. Unshift adds items to the beginning. Alright, here are a few others. Splice, how to delete an element from an array. The arrays are objects, so we can try to use delete. Hold on real quick. I want to change something. I'm gonna change me real quick while we go through this. That's not gonna let me do it like that. That's fine. Give me 1 second. Alrighty. So I'm gonna just read it for now. I'll figure out the camera thing in a minute. So how to delete an element from an array. The arrays are objects, so we can try to use delete. Let R equal I, go, home. That's in the array, name R. Delete the R in the first space, so go, remove go. Alert R1 undefined because, well, it's empty. Now R, the comment, you can read the comment. The element was removed, but the array still has 3 elements, so we can see that R.length is compared to the value of 3. That's natural because delete object.key removes a value by the key. It's all it does. Fine for objects, but for arrays we usually want the rest of the elements to shift and occupy the freed place. We expect to have a shorter array now, so special methods should be used. The R-splice method is a Swiss Army knife for arrays. It can do everything: insert, remove, and replace elements. The syntax is R-splice start, delete count, element 1, blah blah blah, element to the nth degree, and close. It modifies R starting from the index start, removes delete count elements, and then inserts element 1. At their place, returns the array of removed elements. This method is easy to grasp by examples. Let's start with the deletion. Let R equal study blah 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 splice 1 1. So from the index 1, remove 1 element. which is basically study, right? Hey, easy, right? Starting from the index 1, it removed one element. In the next example, we remove 3 elements and replace them with the other 2. In my free time, guys, well, everyone, is that I play the game. I usually play For Honor. It's on my TikTok. I don't have my TikTok here being shared, but you know, that's pretty much where it is. Let me see. Wait, how many chapters is in this thing? What does it cover? Let me see real quick. Quick detour. This is chapter 1. Chapter data types. Chapter data types. Oh, okay. What? Oh, chapter 5. Ooh. Okay. Chapter 5. Okay, cool. Data types. Data types has 12 in here. Okay. Anyway. That's all I wanted to know. Quick detour. Here we can see that splice returns the array of removed elements. Let I study JavaScript right now. Remove for two first elements. Let removed equal r.splice from the 0 index position in 2 elements, which is what they highlighted here. Cool. Alert removed. Yep. The splice method is also able to insert the elements without any removes. For that, we need to set delete count to 0. Let r equal I study JavaScript from index 2. Delete 0. Then insert complex and language. R.splice. Oh, see, I thought splice only had 2 parameters, but apparently it can do more. It can just add after the first 2. Cool, good to know. I study complex language, JavaScript. From the second position, so it's from the second position, it doesn't remove anything, but it adds. Cool. But it said it can add, remove, and insert, remove, and replace. So we got to see it replace next. Okay, cool. Negative index is allowed. Here and in other array methods, negative indexes are allowed. They specify the position from the end of the array, like here. What does that mean? From index -1, 1 step from the end. 1 step from the end. Delete 0 elements. Wait. 1 step from the end. Insert 3 and 4. 1, 2, 3, 4. 1 step from the end. 3 and 4 will go here. Okay. Cool. Alright, I get that. Splice. The method r_splice is much simpler than the similar looking r_splice. The syntax is r_slice start end. It returns a new array copying to it all items from index start to end, not including end. Both start and end can be negative. In that case, position from array end is assumed. It's similar to a string method, string slice, but instead of substrings, it makes subarrays. For instance, let R equal to basically TEST. That's the array. Alert R slice 1 through 3, E and S. So in the first position and third position. Got it. 5. Alert R slice -2. Copy from the -2nd to the end. So this is the end. Second from the end. Okay. Let's see. It removed these? Okay. We can also call it without arguments. Creates a copy of R. That's often used to obtain a copy for further transformations that should not affect the original array. Concact. The method rconcact creates a new array that includes values from other arrays and additional items. The syntax is rconcat argument 1, argument 2, so on and so forth. It accepts any number of arguments, either arrays or values. The result is a new array containing items from R, then argument 1, argument 2, etc. If an argument argin is an array, then all its elements are copied. Otherwise, the argument itself is copied. For instance, let R 1 and 2 create an array from R and 3, 4. Alert R concat 3, 4. Okay. R. The method 3 and 4. So it should end up 1, 2, 3, 4. Alert R concact 3, 4, 5, 6. So it should create 1, 2, 3, 4, 5, 6. Okay, cool. Create an array from R and 3, 4 and add 5 and 6. R concact 5, 6. Normally it only copies elements from arrays. Other objects, even if they look like arrays, excuse me. Give me 1 second, Joe. 1 second. Check something out. All right. Now I'm back. Now, where was I? I gotta get up, get something. Be right back on. Alrighty, everybody, I'm back. So, I'm gonna turn the camera back on. I should have it fixed if it isn't fixed. I don't know what happened. Alright, I see me here. So y'all should see me out there. Hopefully y'all see me out there. I'm gonna give it a second for it to catch up. Clean this camera. Alright, cool. Y'all should see me in a second. Anyway, so we're going through, there you go. But if an array-like object has a special symbol dot is concact spreadable property, then it's treated as an array by concact. Its elements are added instead. I mean, cool, I get that. Or I think I do. Let's look at the example. Let R, the array of 1 and 2. Let array like, so it created an object. Got it. 0, something else, 1 else. Oh, wait. Anyway. There we go. You got it. Turn my foot massager off. Alert R concact array like. So it's concatenating the R and the array like. So 1, 2, something, something else. Something and else. I don't know why I say something and something else. Iterate for each. Now I do understand how for each works to a degree. So to go through everything. Anyway, the r.forEach method allows to run a function for every element of the array. That's much simpler than I would have put that. Okay, and then that's the example. For instance, this shows each element of the array, and then it's Bilbo, Gandalf, Nazgul, for each alert. So it's going to alert Bilbo, Gandalf, and Nazgul. And this code is more elaborate about their positions in the target array. Bilbo, Gandalf, Nazgul, dot for each. Then you have the for each method. Inside of it is the item index array, arrow function, what to do for each item. Alert item is at index in array. Oh, they have a play button. Bilbo is at 0. Okay. Gandalf is at index 1. Nazgul is at index 2. Look, legit. The result of the function, if it returns any, is thrown away and ignored. Searching in an array. Now, hold on. Make sure that this tab, that for whatever reason, sometimes my computer does some. It is my computer. I forget which screen I actually had going or clicked on last when I try to open the code over here. So the methods are r.indexOf and r.includes have similar syntax and do essentially the same thing as their string counterparts, but operate on items instead of characters. On items instead of characters. r.indexOf item from. It looks for item starting from index from and returns the index where it was found, otherwise -1. Or includes item from, looks for item, starting from index from, returns true if found. Usually these methods are used with only one argument, the item to search by default. The search is from the beginning. For instance, let R is assigned an array 1, 0, false. Alert R index of 0. I mean, I got it. I get what it's a learning, I believe. No. -1. Does the array include 1? Yes, that's true. Got that. Please note that index of uses the strict equality for comparison. So value and type. Cool. Okay. So if we look for false, it finds exactly false and not the 0. If we want to check if item exists in the array and don't need the index, then r_includes is preferred. The method r.lastIndexOf is the same of index as indexOf, but looks for from right to left. What? Anyway, that's looks for from. Alright, I read that 3 times, so that's a weird way to put that. I got what they're saying. Let fruits the array apple, orange, apple. Alert fruits index of apple. 0 first. Alert fruits last index of apple. And it'd be the last apple. Man, this document's long. Leon, why? It's so long. Anyway, the includes method handles NaN correctly. A minor but noteworthy feature of includes is that it correctly handles not a number, unlike index of. Const r equals not a number. Alert r dot index of NaN. -1 wrong, should be 0. Alert r includes NaN true. That's because includes was added to JavaScript much later and uses the more up-to-date comparison algorithm internally. There's a lot of these how to search in an array. Apparently find and find index. Find last index. Imagine we have an array of objects. I would imagine we would. How do we find an object with a specific condition? Here, the r.find fn method comes in handy. The syntax is let result equal find r.find function item index array. Okay, if true is returned, item is returned and iteration is stopped. For a falsy scenario, returns undefined. Got that to a degree. I think a lot of these is going to take more than this. And yes, I know you should code with the documentation. I do understand that. This is kind of hefty. Oh, dang, I gotta do the eloquent JavaScript. I'm probably gonna I'm gonna finish this and then we'll do the what is it? And then we'll do the Cold War and then we'll go to class 20. So I have it there. And we can chat along that time. We're gonna take a break in like 32 minutes though. I feel it. Anyway, syntax is got it. The function is called for elements of the array one after another. Item is the element, index is the index, the array is the array itself. Okay. If it returns true, the search is stopped. The item is returned. If nothing is found, undefined is returned. Okay. For example, we have an array of users, each with fields, ID, and name. Let's find the one with ID equals, not equals, that is the value of 1. Okay, ID value 1, name John. It's an object, so the users is an object. Okay, let user equal users dot find. So we're filtering through the item. So in the item, look for item ID of 1. Alert username, which would be John. user.name. Was that necessary? I mean, I got John. Was that necessary? Maybe to explain the idea, but okay. In real life, arrays of objects are a common thing. I mean, I find out. So the find method is very useful. Note that in the example we provide to find the function item ID that has the value of 1 with 1 argument. That's typical. Other arguments of this function are rarely used. The rFindIndex method has the same syntax but returns the index where the element was found instead of the element itself. The value of -1 is returned if nothing is found. The r.findLastIndex method is like findIndex but searches from right to left. Oh, let me see. If this is my left, that's on y'all right. Okay, right to left. It's weird, but searches. Anyway, I said that. Let users, cool. It goes down the. Now it's an array. Is it an array? It's still. That's an array. Now it's an array. That's weird. Okay. This is why it be tripping me up sometimes, but I'll get there. I think it's just more like working more with JavaScript. I'm still inexperienced in that way, so we'll get there. I'm gonna look back on it and be like, oh man, this makes so much sense. Anyway, like it's in plain English. Why didn't I see it the first time? Something like that. Something to that degree. I have a cup, but I'm not gonna store it. I'll be using the monster can, the mega can, because it has a lid. But for streaming purposes, I'm gonna have to pour it in a cup. I don't want anything to strike me. Copyright strike. Because I don't have their permission. Is that what's up? For nothing. I mean, if Monster wants to sponsor me, that'd be dope. I buy enough. All right. Where is them? Got it. Got it. Filter. Yeah, I was describing this. Find the index of the first John. Because there's 2 Johns. Users. Find the index of user. User.name equal John. 0. Find the index of the last John. Alert users. User.name equal John. It's in the third index position. Yeah, so it's an array. Seeing it's the syntax. The syntax is what's holding me down. Because if the whole thing was in curly brackets, then I would have assumed it was an object up until I saw the square brackets. Filter. The find method looks for a single first element that makes the function return true. If there may be many, we can use our filter function. The syntax is similar to find, but filter returns an array of all matching elements. Let results equal r.filter function item index array. So they have it down here. They're using it here. Okay, cool. This is an array with IDs, name, and a name. Sorry. I just started yawning. I'm probably gonna have to make me some tea on our break. Anyway, let me see. Where's the to make sure we follow what they just said? Okay, cool. This is what is supposed to be going on. All right. So let users tracking users, which is all the array dot filter. Got it. A function item, and then into the item ID. Three. I have not seen this like that. I guess the position of 3. This is 2. Oh, less than 3. The less than 3. So I got 2. I need more than that, man. What? No, never mind. I still need more than that, man. Transform an array. Ooh, transforming arrays. Woo! If it didn't get hefty. We ain't even halfway through the document. Anyway. Let's move on to methods that transform and reorder an array. Map. The RMap method is one of the most useful and often used. Phenomenal. It calls the function for each element of the array and returns the array of results. I must be tired person today. I don't feel sleepy though. So syntax is let result equal R and then map function item index array. For instance, here we transform each element into its length. Let links the array Bilbo, Gandalf, Nazgul, map item function item dot length. Alert links 5, 7, and 6. Nazgul. Sort function or sort. This is called the call to our sort sorts the array in place, changing its element order. It also returns the sorted array, but the returned value is usually ignored as R itself is modified. For instance, let R, this is the array, the method reorders the content of R sort, alert R. It's because it doesn't necessarily notice that it just starts with a 1, so it places it here. Did you notice anything strange in the outcome? The order became 115 to incorrect, but why? The items are sorted as strings by default. Okay, cool. Literally, all elements are converted to strings for comparisons. For strings, lexicographic ordering is applied, and indeed, 2 is great. This is greater. String 2 is greater than string 15. To use our own sorting order, we need to apply a function as the argument of r.sort. The function should compare the 2 arbitrary values and return function. Compare AB. If A is greater than B, return 1. If A is equal to B in value, return 0. If A is less than B, return -1. If the first value is less than the second. I got that. For instance, to sort as numbers, function compare numeric A B. So they wrote the whole function here, basically this. Now but to follow the syntax. So you have to do it like that first. In the function, let R equal that array 1, 2, and 15. R sort compare numeric. The function alert R 1, 2, 15. Now it works as intended. Let's step aside and think about what's happening. The R can be an array of anything, right? It may contain numbers or strings or objects or whatever. We have a set of some items to sort it. To sort it, we need an ordering function that knows how to compare its elements. The default is a string order. The R sort method implements a generic sorting algorithm. We don't need to care how internally it works. I tried to stop yawning. That's why I did that. Works in optimized quick sort or time sort most of the time. It will walk the array, compare its elements using the provided function and reorder them. All we need to do is provide the fn function which does the comparison. By the way, if we ever want to know which elements are compared, nothing prevents us from alerting them. Fair. 1, -2, 15, 2, 0, 8, dot sort. Put an array method, sort, and a function inside of sort, AB. Function is this. Return A minus B. So it's going to be -2, 1. That's an odd way to put that. Well, it's walking through all of them, all the way up to 8. That's cool. That's cool. I'm sure it's handy. I don't have an idea of how to use that quite yet, though. So, I'm sure I will. I'm sure I will. So, we're going to let's discuss a few things that we learned so far. So far, we went through, and we're going to look in here, right? Well, I'm not going to, you know what? Yeah, why not? Let's start all the way at the top. We learned how to make an array, right? Here's what we learned about. Wait a second. What'd you do? Why'd you do that? Okay. I must have done that. I don't know how I've done that, but it's cool. Wow. I didn't mean to split it. Go back. Anyway. I gotta stop doing that. It's like, man, I'm just going through here like I'm just fumbling around for real. Wait. Okay. So we learned how to make an array. Crow, Leviathan, Olympus has fallen, and Gambit. Those are all movie titles. We understand that this part is declaring a variable. This is how you assign the variable. That's what the equal sign is in assignment. Comparison uses two or more, which is what you would use for a function. Right? Movie title for each. We learn how to iterate through it through the document.query selector and the text plus movie title. We'll learn how to iterate for each. Because the first one is the actual element, and this, yeah, it's right there. And then I is the index number, which is why I put I, and it goes through it like that. So I get it. I mean, I'm not gonna do a thorough review, but that's pretty much what I get the gist of. I ain't gonna lie, tired, bored, for one. Although music is playing and stuff like that, I'm bored. I ain't gonna story. I'm bored. I know that Leon has this as like required reading. I did the JSWay arrays and the JSWay objects. I need to do a Cold War. If I watch one of the videos, I'm gonna be bored. I know I am. So, let's see. What we do in the meantime then? I mean, we could doom scroll. I'm not into doom scrolling. Although that does sound like a nice pick me up, I suppose, but that could last forever and a day long and not to task. So what is something else we could do? I wonder. What is something else we could be doing? I'm gonna start breaking it up in I know exactly what I'm gonna do. I'm gonna break it up in like 30-minute intervals. I'm gonna take a break. Apparently I started streaming 45 minutes ago. That's pretty good. Woo! So, yeah, no. I'm gonna go ahead and take a break and be back. I'll take a break and be back. That's crazy. I ain't even got mine. I don't even have it set. Interesting. Why didn't I have it set already? I understand 5 minutes for some, but 5 minutes ain't gonna cut it. I'm not even gonna story. So, gonna go ahead and take a break, and we'll be back. And I still got my water. Alrighty. I love my tea. Love my tea. Anyway, so that's the break minute a little extended, but I feel better. Alright, let's get into it. We talked about this. Yep. The algorithm may compare an element with multiple others in the process. Let me make sure we're... Hey, can y'all hear the music? If you couldn't, you should be able to now. Okay. Let me see. Try to make sure at least I'm higher than it. All right. So the algorithm may compare an element with multiple others in the process, but it tries to make as few comparisons as possible. A comparison function may return any number. May return any number. Actually, a comparison function is only required to return a positive number to say greater and a negative number to say less. That allows to write shorter functions. Okay, cool. Because that was a lot. Let R, the array, R short function, A, B, return A minus B, alert R. Arrow functions for the best. Remember arrow functions? We can use them here for neater sorting. R sort. This works actually the same as the longer version above. Okay. Because arrow functions inherently return. So return AB. This works exactly the same as the longer version above. Cool. If I said that twice, forgive me. Use local compare for strings. Remember strings comparison algorithm. It compares letters by their codes by default. For many alphabets, it's better to use string.localCompare method to correctly sort letters, such as, I don't know what that is. What is that symbol? Ooh. For example, let's sort a few countries in German. Oh, okay. Okay, let countries array, Ostrich. I don't know how you say all of these, but I'm gonna try. Andorra, Vietnam. Alert country sort, AB. Arrow function A greater than B, ternary. So if A is greater than B, then 1. If it isn't, if it's false, -1. Alert countries dot sort AB. Arrow function A dot locale compare B. This closes sort, and this closes the alert. the method R reverse reverses the order of elements in R. For instance, let R equal 1, 2, 3, 4, 5. Okay, that's the array. R reverse 5, 4, 3, 2, 1. Okay. It also returns the array R after the reversal. Hold on real quick. Gotta look something up. I'm not placing it here because, well, it's about something else. Give me 1 second, yo. Y'all ready? That's all I need to research. Okay. Here's where we were. We did the countries, did that. Now let's see how that works. Okay. Reverse, went through reverse. Split and join. Did that. Oh, goodness. I gotta, hold on. All right, back. We're back. Split and join. Here's the situation from real life. We're writing a messaging app. The person enters the common delimited list of receivers: John, Pete, Mary. But for us, an array of names would be much more comfortable than a single string. How to get it? The string dot split, so the string method delim does exactly that. It splits the string into an array by the given delimiter. Delim. In the example below, we split by a comma followed by a space. Let names: Boba, Gandalf, Nazgul, let array equal names dot split. So it splits it by the space and the comma. So now it's an array. 4, let name of R and alert backticks a message to name period backtick. Cool. So each one of them is going to get a message, basically, that says a message to whoever, right? The split method has optional second numeric argument, a limit on the array length if it is provided, then the extra elements are ignored. In practice, it is rarely used though. Let R split by them, and I guess the first two, which would be Bilbo and Gandalf, which is what they alerted. Cool. The call r.join glue does the reverse to split. It creates a string. It creates a string of I don't know what's going on. What is it doing? Well, my kids got school out. Well, I knew that, but anyway, split into letters. Call the split with an empty s would split the string into an array of letters. That string it would test alert string the split method. And TEST. Okay, see, I was curious. You just make it empty. And I got it. The call, I guess that's the join array method. Glue does the reverse to split. It creates a string of our items joined by glue between them. Let R, the array that we had before, let string equals R join, glue the array into a string using the semicolon, alert string. So instead of them having a space, they'll no longer have a space. Okay, cool. Anyway, reduce and reduce right. I heard this is super beneficial. There's a couple of them that I heard were super beneficial. So anyway, we need to iterate over an array. We can use for each, for, and for ... of. When we need to iterate and return the data for each element, we can use map. The methods rReduce and rReduceWrite also belong to that breed, but are a little bit more intricate. They are used to calculate a single value based on the array. The syntax is let value equal r.reduce function accumulator item index array. Initial is at the end. That's interesting. The function is applied to all array elements one after another and carries on its result to the next call. Arguments. Accumulator is the result of the previous function call. Equals initial the first time if initial is provided. Item is the current array position. Index is its position. Array is the array. Okay. As the function is applied, the result of the previous function call is passed to the next one as the first argument. So the first argument is essentially the accumulator that stores the combined result of all previous executions. And at the end, it becomes the result of reduce. Sounds complicated. The easiest way to grab that, because it did, it really did. It really did. Like, I read it, I got some of it. It's still complicated. The easiest way to grasp that is by example. Here we get a sum of an array in one line. Let R equals the array 1 through 5. Let result equal array reduce sum current. Sum plus current 0. Alert result 15. Let me see. So 10, 15. Yeah, that's right. Function passed to reduce uses only 2 arguments. That's typical enough. Let's see the details of what's going on. On the first run, sum is the initial value. The last argument of reduce equals 0, and current is the first array element equals 1, so the function result is 1. On the second run, sum equals 1. We add the second array element 2 to it and return. On the third run, sum equals 3, and we add one more element to it, and so on. Calculation flow. 0 plus 1 plus 2 plus 3 plus 4 plus 5 equals 15. Or in form of a table. I mean, I got that. I don't need that. Here we clearly see how the result of the previous call becomes the first argument of the next one. We also can omit the initial value. I get it. See, I like JSWay, but JSWay it's not as in detail, or at least it doesn't feel like it, but it is definitely easier for me to comprehend. So I get that, and this is just more in depth, and it's not such a brief read. So I get that. That's probably why you should break these things up throughout a day. So that's cool. Because at the end of this reading, I'm gonna take a break, re-energize, and then be back to it with the Cold War, and then from the Cold War, jump into the next topic. Really, the result is this. All right, so got it. Did that, read that. The result is the same. That's because if there's no initial, then reduce takes the first element of the array as the initial value and starts the iteration from the second element. The calculation table is the same as above minus the first row, but such use requires an extreme care. If the array is empty, then reduce call without initial value gives an error. So it's advised to always specify the initial value. The method rReduceWrite does the same, but goes from right to left. Array.isArray. Arrays do not form a separate language type. They are based on objects. So type of does not help to distinguish a plain object from an array. Alert type of object. Alert type of object, same. But arrays are used so often that there's a special method for that. Array dot is array value. If it returns true if the value is an array and false otherwise. Alert dot is array, which would be this, false. Right, because that would indicate an object, I would guess, and this would indicate that it is an array. Most methods support this arg. Almost all array methods call functions like find, filter, map, with a notable exception of sort. Except an optional additional parameter, this arg. That parameter is not explained in the sections above because it's rarely used, but for completeness, we have to cover it. See, more in detail. Here's the full syntax of these methods. r.find funct this arg, r.filter funct this arg, r.map funct this arg. This arg is the optional last argument. The value of this arg parameter becomes this for funct. Oh, okay. Which we covered in the other video, right? For example, here we use a method of army object as a filter, and this arg passes the context. Let army equal min age 18, max age 27, can join user. So this is an object of the army. Can join is a method inside of the army. It's going to, with the argument parameter of user, and the function, the method or function returns user age is greater than or equal to this dot min age double the logical and user, and the user dot age is less than this max age, then they can join. Let users equal, now it's an array of ages. Age 16, age 20, age 23, age 30. So is the array a container of objects? I don't know. We'll find out. Okay. Find users who army.canJoin returns true. Let soldiers equal users.filter army.canJoin and then army. Alert soldiers.length 2. Alert soldiers 0 age. So the first one says 20. So the first one that can join is 20. And the other one that can join is 23. So basically on line 11 and 12, because they're too young and they're too old. Although they did move the age to like 32, 34, something like that. Okay. If the example above we used users.filter army.canJoin, then army.canJoin will be called as a standalone function with this equal undefined, thus leading to an instant error. A call to users.filter army.canJoin army can be replaced with users.filter user arrow function army.canJoin user. That does the same. The latter is used more often, but it's a bit easier to understand, for most people. And see, okay, I understand the last one more than the other ones right now. Cheat sheet summary. They cheat sheet long. I know Leon wants to complete the task, but I'm not gonna store. Not right this instant. It's not doing that right this instant. Summary. Cheat sheet of array methods. To add, remove elements. We got push that adds items to the end. Pop extracts items from the end. Shift that extracts an item from the beginning. Unshift adds an item to the beginning. Splice, which needs the position, delete count, and item. And it can insert items. Yeah, the position and deletes, and then it adds whatever items at the end. This is 3 or so parameters. Slice, start and end, creates a new array, copy elements from start till end, not inclusive. Concact returns a new array, copies all members of the current one and adds items to it. If any items is in an array, then its elements are taken. To search among elements, index of, last index of, item, and position. Look for item starting from position. and return the index or -1 if not found. Includes value. Returns true if the array has a value, otherwise false. Find filter the function. Filter elements through the function. Return first or all values that make it return true. Find index is like find, but returns the index instead of value. To iterate over elements, the for each, and then with the function passed in as a argument. Calls func for every element does not return anything. To transform the array, we have map with the argument with a function as an argument. Creates a new array from the resulting calling function for every element. The sort, function call with a function inside of the sort. Function call as an argument. It sorts in the array, sorts the array in place, then returns it. The reverse function call reverses the array in place, then returns it. The split/join converts a string to an array and back. Reduce and reduce right function initial. Calculate a single value over the array by calling function for each element and passing an intermediate result between the calls. Additionally, array checks value for being an array, and if so true, otherwise false. Please note that sort, reverse, and splice modify the array itself. These methods are the most used ones. They cover 99% of use cases, but there are a few others. r.sum and r.every check the array. The function fn is called on each element of the array, similar to map. If any/all results are true, returns true, otherwise false. These methods behave sort of like logical OR and logical AND operators. If the function returns a truthy value, r.sum immediately returns true and stops iterating over the rest of the items. If function returns a falsy value, r.every immediately returns false and stops iterating over the rest of the items as well. We can use every to compare arrays. I'm not going through that. r.fill fills the array with repeating value from index start to end. r.copy within copies an element from position start to position end into itself at position target. Okay. r-flat create a new flat array from a multi-dimensional array. For full list, see the manual, which is MDN. The almighty MDN. Whew. Alright, y'all, we made it to the end. We made it to the end. Ain't that wild? And it's still stuff to do. There's still stuff to do. Anyway, but for right now, that's gonna be it. I'm gonna take me an entertaining break, and I'll come back. Catch y'all. See y'all later today. Thank you for studying with me.